Let's study effectively with Miss ICT Skill Builder.
Every day, you make dozens of decisions based on specific conditions. For example, before you walk out the front door, you check the weather. If it's raining, you grab an umbrella. If it's sunny, you take your sunglasses instead. You assess the condition, pick a path, and act on it. Computers process decisions the exact same way. In programming, this process is called selection. It is the mechanism that allows code to look at a piece of data, ask a question with only a true or false answer, and choose which action to take next. Without the ability to make choices, algorithms would be entirely rigid, running the exact same sequence of instructions every time, regardless of what happens. Selection provides the flexibility for a program to adapt to different user inputs. To build a selection statement, we use a specific structure. It always begins by defining a condition using the word if. This condition functions as a question that can only be answered with true or false. Look at this grading rule. If marks are greater than or equal to 50, then pass, else fail. If a student receives 60, the condition evaluates as true, outputting pass. If the score drops to 40, the condition is false, resulting in fail. This if-then-else structure acts as a literal fork in the road for data. It is the core mechanism that controls the flow of information through any software application. Before writing out lines of code, developers often map out these decision forks visually using flowcharts. The universal symbol for a selection statement is the diamond. Here we see the standard diamond symbols. Inside the shape, you place the true or false condition. Crucially, exactly 2 arrows must point away from the diamond, representing the only 2 possible outcomes, true and false. This flowchart asks for user input. In the middle, the decision diamond checks if the color equals purple. If the user types purple, it's true, and logic flows right, outputting, I like purple too. If any other color, it's false, bypassing that box entirely. Tracing these lines allows programmers to verify they have accounted for every possible scenario, ensuring data won't hit a dead end once the actual code is written. To actually build the questions inside those decision diamonds, you need a way to weigh different values against each other. Computers handle this using a specific set of mathematical symbols called comparison operators. This table outlines 6 standard programming operators, like greater than and less than. Notice the equal to operator uses 2 equal signs, which checks if values match. Finally, the not equal to operator checks if 2 values are completely different. Pay close attention to these symbols. Accidentally using a single equal sign when you meant to use a double is one of the most common reasons a program will crash. Sometimes, a single comparison is not enough. When a decision requires checking multiple conditions at the exact same time, programmers use Boolean logic. The AND operator is strict. Think of it like 2 locks on a single door. If our conditions state that age must be greater than or equal to 13 and less than or equal to 19, both locks must clear. If even one fails, the entire statement evaluates as false. The OR operator is much more flexible. If you are checking whether the day is Saturday or Sunday, only one of those conditions needs to be true. Succeeding on either path gets you to the weekend. Finally, the NOT operator has a single job. It reverses the logic of your condition. If a statement evaluates to true, NOT flips it to false. If it is false, NOT flips it back to true. By combining comparison operators with AND, OR, and NOT, you can write programs capable of handling complex, real-world rules, rather than being limited to highly restrictive single-variable questions. Let's put this into practice with a logic block checking a compound condition. We have if age is greater than or equal to 13, and age is less than or equal to 19, then output teenager, else output not teenager. Our starting variable is an age of 15. Pause the video right here, look at the operators, and manually trace the logic path for this specific variable. The number 15 is greater than 13, making the first condition true. It is also less than 19, making the second condition true. Because the AND operator requires both sides to be true, the entire statement succeeds, and the program outputs teenager. Tracing variables step by step like this is the definitive way to verify that a complex algorithm functions precisely as you intended. You now have a complete logic toolkit. You know the structural if-then-else framework, how to map it visually with decision diamonds, the comparison operators to build your questions, and the Boolean logic to combine them. When you are testing algorithms or answering exam questions, do not stop once you find the true path. Always trace the false path as well to ensure there are no logic gaps hiding in your alternate scenarios. Thoroughly testing both sides of the decision tree ensures you maintain absolute control over your code's behavior, no matter how complex the data gets.
Thanks for watching. If this helped you clear up the concept, hit that like button and share it with a friend who might be struggling with it too. Let's build those skills together.